So, are you saying that if we all cooperate and possibly get like a group A would give us...
Then I'll make the test harder. I know, just kidding. All right, so section 1-2 talks about graphs of functions. So we talked about what a function was. So now we're going to specifically look at graphs of functions. So example 1. We're going to find the domain and the range from a graph. So your domain is what kind of values? X values. And so X goes right and left, doesn't it? So your domain are X values. So when you look at your graph, you're going to look right and left. Whereas the range is what kind of values? Y values. And Y values on the coordinate grid go up and down, don't they? So you're going to look at the graph up versus down. If you can get that in your brain, looking at the domain and range should be simple. So let's look at example 1. As I look from left to right, what is my leftmost number? Right here, correct? And that's negative what? 2. So that's why the domain starts at negative 2, and notice it has a bracket, because this is a closed circle right there. So negative 2 is part of the, it's a solution to the function. And if I go all the way, what's the rightmost number here? This is the rightmost part, and so that right there is 4. But notice it's really hard to see. Isn't that an open circle? So it gets as close to 4 as possible, but not actually 4. So when we hit 4, we have an open parenthesis, right? Not a bracket because of this open circle. So write yourself a little note here, open circle. Open circle means parentheses. Closed circle means bracket. Oops, I guess I could put that in brackets. So that's why when you look at the domain, notice that the domain is written in interval notation. You need to write it in interval notation. It's the easiest way to show it. All right, so then look at the range. The range, you're going to look at your highest versus your lowest value. So you want to be going up and down. So as I go up here, isn't this the highest point on my graph right here? What Y value is that? Don't look at the X value, look at the Y value. That's 2, and it's a closed circle. So we have a bracket at, well, okay, they're going backwards, and I'll tell you why in a minute. Don't negatives come before positives? Okay, so that's why the 2 over here has a bracket. And then the lowest value on the graph is down here, isn't it? What's the Y value? Negative 2. So, and it is a closed circle. So we have a bracket at negative 2. Y goes to positive 2, and there's a bracket there. So in other words, in this function, you're only going to have Y values, output values, that go from negative 2 to positive 2. Your X values are only going to go from negative 2 and up to 4, but not including 4. Because this is not a continuous function. It stops. All right, so you look at the next one. I want you to write what you think the domain and range are for this graph right there. Use interval notation. All right, what is domain goes left and right. So what is your leftmost value for domain? Yeah, this is my leftmost value. So if I go down here to the x-axis, that is negative, what? Negative 5. And it's a closed circle, right? So we want to put a bracket at negative 5 and then go all the way to the right. This is the rightmost point. It's an open circle and it's at what? 4. So I want to put comma 4 and then parentheses, right? Because it doesn't include 4. Then your range, which are your y values, we go up and down. So let's go down first since that's our left part of our range. Isn't this the lowest point up and down? That's my lowest point right there. What's that y value there? -3. And it's a closed circle, so it includes -3. And then my highest point is not here, it's here, isn't it? And so my highest point goes over here to what? 4. Does it include 4? Yeah. So that's not so bad, is it? The hard part is going up and down and keeping track of what axis you're actually looking at. It does. Yes, it does. Because you have to go from the smallest to the greatest. So good question. And I tend to go on the range up and then down. So I have to force myself to remember to go down and then up. All right, so let's look at example 2. Oh, we didn't talk to see whether these are functions. So remember to use a vertical line test to tell if it's a function or not. Is this one a function? Yes. So this is yes, a function. What about this one? Yeah, there's no place that I put a vertical line that it passes it more than once. So this is a function. What if I turned it this way?
No.
Now it's not a function if I had the graph this way because it's hitting it more than once. Same thing here, right? Right here would make it not a function. Good thing we're not turning it sideways. All right, so let's look at decreasing and increasing functions and then what their intervals look like. So as you look at this graph, we always go from left to right. Think of how you read. We read from left to right. Numbers go bigger from left to right, correct? So as I approach the graph from the left, starting here and going to here, isn't the graph decreasing according to y values? It's going down, isn't it? So this part is decreasing. And so look at the numbers between the x values between which is decreasing. It decreases from an x value of -2 to 0. Now notice how we write the interval. It's with parentheses. You're like, but we have closed points. This is true, but at some point there is a transition point. And the transition point occurs from here where we could have gone up, down, right, or left, or whatever direction. We tend to go down. We always have an open interval. And your intervals are always defined in terms of x, even though we look at how it's increasing or decreasing against the y-axis. We always define the intervals in terms of where is it on the x-axis. So this decreasing interval is from -2 to 0. Then we have a constant interval, meaning it's not going up, it's not going down here. So right here is constant. And it's constant from 0 on the x-axis to 2 on the x-axis. And so that's why you see the interval 0, 2. These are not ordered pairs, they're interval notation. And then finally we have increasing right here. And it's increasing starting at 2 and stopping at 4. So from 2 to 4, it increases. Not every graph will have a decrease, an increase, or a constant. Joy, your head needs to be off your desk. Then, haven't we talked about relative max or mins before? Okay, take out your calculator. How many clocks do I need to get out? 1, 2, 3 still? Excellent. Joy, you have a calculator? Yeah.
So the screen of my calculator is like super large and change the values in it. Is there anything I can do to fix it?
No. You might want to go in and talk to the power setting. Because I know nothing about that. I'm technically retarded. Oh, yay! Is that this year's?
Yes.
That is awesome. You have a little world on there? They've not done that before.
Well, do you understand
No.
the horizon?
Oh,
Maybe I would mind that.
That's great. It's a lot more creative than I would have been.
And then all the other kids, it's a paw print with a motherboard behind it. Technology.
A paw print with a who?
Motherboard.
Oh. Oh. It surely is. That's fascinating. All right, so you are going to find a calculator to find your relative minimum and maximum. So that is your range values, isn't it? Now, on this particular graph, because it is a continuous function, in other words, it doesn't ever end, ever, but we're going to find where it relatively has a maximum and relatively has a minimum. Otherwise, it'd be infinity and negative infinity, because it's going to go either all the way up, all the way down, or one in each direction, depending upon what type of function it is. So go ahead and put this in your y equals. Make sure that your window before you start off with is normal. Is my window standard? No. So I need to fix my window. Make sure you're using your negative button and not the subtraction button. Alright, so that's in your y equals, and then hit your graph button. Now here's where I'm going to be a little picky about how you sketch your graph that you take from your calculator. I need you to find out where that graph is crossing the x and the y axis. So it's really tight to the x-axis, isn't it? So how do you find your intercepts? Where do you find the x-intercepts? Under what menu? Calc. So go to second calc, go to what? Zeros. And it's asking you for left bound. So I want to go to where it's above the x-axis. So it's above there. Hit enter. Go below the x-axis. That's your right bound. Hit enter. And then guess. Make sure that your y down here shows 0, which it does. And so my x is -1. So I'm going to plot a point at -1, 0, right here. Where else does it appear to maybe cross? The origin, and we'll fix that in a minute. We can find the origin one on our table of values, because that's also the y-intercept, isn't it? Looks like it could be. So let's go ahead and find this one over here. So I'm going to find the second 0. So this time I need to make sure I'm below the x-axis. Hit enter. Oh, I did that wrong. I need to be above the x-axis and then below, because it's so tight in here. You could zoom in if you wanted to. So I'm going to cancel this. Cancel, cancel. Oh look, I got 0, 0 anyway. So there is one at 0, 0. And then I'm going to find the second one, or the third one. So I'm just a bit above, and then I'm going to go below. And then guess. And so I am at 1, 0. So you need to kind of sketch how that looks on there. And so it looks just kind of like this. Right? Give or take a few. Here's the other thing that I'm not seeing that I didn't see on your chapter P test. I want these labeled as close to them as you can. If you have to put arrows, that's fine. So this is 1, 0. This is 0, 0. And this is -1, 0. I am looking for those critical values, your x and your y intercepts. Once I'm assured that you understand that that's where it is, I'm okay with the rest of the shape of the graph, as long as it's close. All right, so then, how do you find your relative max or min? What menu on your calculator? The who? The calc. So do second calc. And what are you looking for? We're looking for either choose max or min, right? Then you're going to do one of each. So here's my second calc. I'm going to start with a minimum. Is that where my minimum would be? On that side? Nope. So I want to scroll to where I would be to the left of my minimum, which is there, and then to the right of my minimum, which is there, and then if you're not told, and this is a decimal, if you're not told where to round, how many places should you round? I would round 2 places and round correctly. So my x is negative 0.5 is going to be an 8. So my minimum is negative 0.58, comma. There's Nelson sneezing. And then my y is negative 0.38. Well, we're not going to go to 3, so just negative 0.38. And then look for your max. Second calc, find maximum. Go to the left, so there's my maximum. Go to the left, go to the right, and there we go. So then my maximum x value is positive 0.58. And then positive 0.38. And they won't always mimic each other. This particular one does. Question? For the maximum, because I knew that that would be the relative maximum up there, I moved it to the left, like right here. You don't want to move it too far left. And because those turns are so close together, you want to make sure that you're not like way over here. Does that make sense? You want to get as close to where the transitions have taken place. So I got pretty close to the 0, 0. And then my right bound was underneath the x-axis. Okay. And then I hit my enter. So if you have trouble, I can help you with that later. All right, so can I flip this? Okay, let's look to the back. Oh, some fun graphs. So we won't need our calculators for the rest of this, so you can put those away. So the greatest integer function seems to give you the most trouble. And here's what it's saying. The minute you see these double brackets right here, it's saying the greatest integer less than or equal to x. Just depends on what x is. So let's say that I was going to do f of 2. What integer, what's the biggest integer that's less than, did I say equal to? It should not be or equal to. You're going to get confused with that verbiage. Really, the greatest integer that's less than x. I'm not even going to say or equal to here. Because if I put 2 in here, look at where the graph is. Here's 2 right here. And if you go up on the graph, that's an open circle. What does that mean? Can 2 be an answer? Oh wait, what does it say here? What's this ordered pair right here? Where that open circle is. Where's that order pair?
2.
X is 2, what's y? 1. So the output is 1. When the input is 2, the output is 1. So the greatest integer that's less than x, and in this case x is 2, the greatest integer that's less than 2 is 1. But what if I had f is 1.8? Well, here's 1.8 here. Go up here. Isn't it still 1? The biggest integer that's less than 1.8 is 1. Well, what if I got to f of 2.1? Now 2.1's over here. Go up to your graph. What is it saying the answer is? Not 3. 2. The greatest integer less than 2.1 is 2, right? So all it is like a slide function. You're not going to have any answers that are outputs that are decimals. Every output is going to be an integer. And so that's what it's showing. It's called a step function. Once you reach this next level, it's kind of like if I'm in a carpet cleaning business and I charge you by the hour. But let's say that I work an hour and 53 minutes. Okay, that one's going to look a little backwards. If I charge an hour and 53 minutes, I'm really going to charge you for 2 hours worth of work, aren't I? Yes or no? So for that one, wouldn't my closed circle be on the right and my open circle be on the left? Do you see what I'm saying? Because, well, think of it this way. What if I worked 1.8 hours? Am I going to charge you for just 1 hour worth of work? I'm going to go to the integer that's greater than, the next integer that's greater than 1.8 in that situation. So sometimes your open circle is going to be on the left. It depends on what the real life situation is. And so you're going to have a couple of those in your homework, and we can talk about it when it gets there. But if I'm billing you based upon hours, I'm going to round you up to the next hour. So in that case, my open circle is going to be switched with the closed circle. The step function will still look the same, but that open circle is going to change. And so the easiest way to figure this out is to come up with some ordered pairs and plot them and see what happens. Okay, so then look at your piecewise functions. I love these, which is usually code for you don't. All right, so let's look at these. We've got two different functions here, but remember these are the domain restrictions for the functions, and it is restricting it at the critical value of 1. So isn't this a linear function y equals mx plus b? Okay, where does this cross the y-axis?
3.
At 3. So plot a point at 1, 2, 3, and I'm using a pencil for a reason, because I'm going to erase part of my graph. And then my slope is 2, right? So up 2 to the right 1, or down 2 to the left 1. But what does my restriction say? X has to be what? X has to be what? Less than or equal to 1. Here's 1 on the x-axis. So just so happens that that's my rightmost point. This is my restricted zone right here, right here. This value, my value for x for this function, has to be less than or equal to 1. Isn't that to the left? I want only the part of the graph that goes to the left of, and I'm going to put, and this should not be part of your graph, but for note purposes, this is the critical value zone. In other words, that's where you're trying to determine what side of the graph your graph is going to be on. And because it's equals to, I do have a closed circle here, and then an arrow going down. There's more to this graph. It goes in that direction infinitely, but I'm restricted. X has to be less than or equal to 1. Look at the next one. Where's the y-intercept on this one? 4. So 1, 2, 3, 4, plot a point at 4. Your slope is -1. So you're going to go down 1 to the right 1, down 1 to the right, down 1 to the right. Okay? But my restriction is that x has to be greater than 1. Here's my boundary point at 1. Do I want this point over here? No. So I'm going to erase that point because it's past my restriction. What am I going to do with this point right here? Is it part of my solution? Greater than 1. Is it part of it? So if it's greater than 1, shouldn't this be an open circle right there? Right? And then I only want the values that go to the right of here, and this is the part of the graph that's to the right of that boundary line. So I'm going to continue it this direction and with an arrow. So those are the only parts of those lines that I want on my graph. Notice that the domain is not restricted on here at all, because right here I have a closed circle. So my domain is all real numbers. My range, however, stops up here, doesn't it? My range is going to be from -infinity to 1, 2, 3, 4, 5, right? -infinity to 5. So they could ask you what's the domain and range on these functions. All right, look at the even odd. You had this in 3-4. Depending on your teacher, depends on what they taught you. Here's my opinion, or here's what I would do if I were you. To determine if you have an even function or an odd function, you're always going to plug in negative x. Replace x with negative x for x. For even functions, you get the same answer that you started with. So for example, look at what happens. If I take the function right here, and I want to prove that if I replace x in this function with negative x, I should still get the same exact function I start with. So here's my function. I'm going to replace every x I see here with a negative x. What's a negative x squared? What's a negative x squared? Just x squared plus 1. Is this any different than this? What do you notice about these two? This is the original function. What's my new function when I plugged in negative x? Are they the same or different? They're exactly the same, right? This is an even function. If your signs change to exactly the opposite signs, it's going to be an odd function. So look at what happens over here. This is saying that if I plug in a negative x, I'm going to get all the opposite signs on my function. My function is essentially going to be multiplied by negative 1. So let's try it on this one. So every x, I'm going to replace with a negative x. What is negative x cubed? Negative x cubed, right? What's a negative times a negative x? What's a minus minus x? Plus x. Now I want you to compare this to the original function. Look at these two, compare. For it to be an odd function, all signs change to opposite sign. Is that what happened here? The x cubed became negative, the negative x became positive. All signs changed. This is an odd function. Well, what happens if one of the signs changes but the other one doesn't? What happens if not all signs change? Then it's neither. If all signs don't change, it can't be odd. If it doesn't stay the same, it can't be even. Therefore, you would say it's neither. All right, the last part. Here is this function right here. The x squared plus 1 is right here. Its vertex is on the x-axis at positive 1, and it has these points. Do you see how this is symmetrical to the y-axis? And that's all that this is saying. If it's an even function, it is symmetrical to the y-axis. This graph right here is going to look like this. It's the one we just did. And it looks like this. Only it's going in opposite directions. So notice that, and I don't know if you realize this one's actually symmetric to the origin. So on this one, both of your x and y values are going to be opposite values, whereas on this one, your x values are opposite, but your y values are the same. So ponder that, study it for a bit. And we'll talk more about what even and odd graphs look like.